Hi guys, welcome back to Ixy Labs. It's a great day for us. I'm sitting here with my friend Mihály Köllő, who is an experimental neuroscientist. And we will be talking about our perception of reality, our biases, and our arms race with AI. Would you like to say a few words about yourself and what you do and how did you end up in our little show?
Yeah, so hi everyone, my name is Mihály. I have a PhD in neuroscience, and when I started my research, I looked at very low-level questions, like where molecules are in a neuron, and then I started to move more towards larger-scale questions. And at the moment, I'm mostly interested in systems neurophysiology, which tries to understand how large populations of neurons, brain cells, interact with each other, and how this thing produces behavior that we actually can see from the outside. And so for a long time, this whole field was a very theoretical one, because we simply didn't have the tools to test whatever we found out or hypothesized. And in the last couple of years, we started to make tools that now allow us to record from thousands of cells at a kilohertz resolution or 10 kilohertz resolution that we really need. And so this is a very exciting time for this field, because we will start to be able to test whether all our assumptions were true. The work that I've been doing in the last couple of years is developing a technique for recording from many brain cells and interacting with many brain cells. And so Proteomics is a startup that started to try to push this towards clinical applications, and so to connect humans to machines at much higher bandwidth than it was possible before. And we will use this technique for academic research, for understanding the networks. It will be very useful for that. Heron is another startup that I founded a year ago. It addresses a very different problem, which we think is one of the biggest problems with experimental science at the moment, which is simply the sheer volume of it. That we have more than 1 million papers every year coming out in biology, and nobody really reads them. And we like to think that most of that is rubbish, so you don't have to read it, but that's not necessarily true. And the filters that we apply to read just a very small fraction are not very good. So we are trying to use AI to extract data from papers and put it in a system, into a kind of a map-like interface where you can understand better what is out there and what is known already.
In recent years, there's been an increasing talk about bias in decision-making, how bias work. Everybody wants to improve their way of thinking fast, thinking slow, thinking outside the box. Why do you think is this becoming a trend? And what are we really talking about when we're talking about bias?
Yeah, so bias is definitely very important. I think in general about decision making and learning, the critical thing is that we always have to work between different trade-offs. So, and there are many of them. So, for example, there is the exploration-exploitation trade-off, which means that when you go to a restaurant, for example, you have to choose something from the menu. You could choose something that you know is not too bad, like hamburgers, or you could choose something fancy that you don't really understand, and I'm not sure what that means. And that taking a bit of risk, which may lead to a much better position, and actually learn about a new food that you never known before.
And maybe that's going to be your next favorite, right?
Yes, exactly. So it can be shown that the optimal decision-making process involves some error because of that, because it has to explore and not just stick with whatever was good at the first time and then stick with that. So that's one of them. There are other trade-offs, such as accuracy speed trade-off, for example. So obviously, for example, so when you encounter any event in the environment, you can either spend a lot of time to really fine-tune your senses and figure out exactly what's happening and have an absolute certainty about what you are encountering, or you can make a snap decision and act. And so this, of course, depends on what is the expected reward value of that thing that we encounter. So, for example, if you looking at the predator, then it makes much more sense to actually make a snap decision and run away, even if sometimes it's just rusting of the reefs or whatever.
It's a vegetarian lion.
Exactly. Yeah. So so that's another one. And a third one, which is I think very important in biological systems, is that biological systems are very limited in terms of energy. So we have that much energy that we can use in our brain. If you want to put numbers on it, it's something about 10 watts for the brain, 10 to 20 watts. And so with this, your brain is already the biggest power consumer in your body of all the organs. And it cannot really go further than that. So it's you have to do everything, all your decisions, everything you do within this.
Do you think that the reason why we're increasingly talking about these topics is because we are no longer dealing with predators, right? We are dealing with our lives spent increasingly online, where we're being bombarded by systems that anticipate our decision making, and it's becoming a bit more complicated to even realize, oh my god, I've just made a decision, or what do I want? Actually, what do I want to eat? I mean, it's a completely different thing to look at a menu when a hamburger, they know that you like hamburger and it's basically just a hamburger and everything else is kind of small print, right? Then did you make a decision? How do you see these changes? How did our environment change?
So I think what changes a lot is two things. First of all, that the rewards become more difficult to predict. So when it's a question about whether you're hungry or not hungry, it's very easy to make an estimation of what the reward will be. If you have a nice fruit you eat, it'll probably be fine. But as we go further as culture and society evolves, it becomes more and more distant, and you have to make very complex models about what a certain decision will actually mean for you in the future. So that's one of the things that changed a lot. I think the other is that we are much more connected. So we are connected to much more people in much more many ways. And so both of these things actually, I think, make us more vulnerable to kind of society level forces. And that's when game theory comes in. And then basically we become more vulnerable to manipulation, because people can interfere with the way we make our decisions by modulating or what our expected reward value is for a certain thing.
Is this a new thing?
I think it's more, for example, I feel like in social media what happens is that companies became really good in messing with your strategy in the exploration-exploitation trade-off, because it kind of promises you that it feels like you're exploring, but in reality you're not really encountering new information. So kind of companies learned how to masquerade repeating patterns as something novel and exciting.
Right.
First, when we encounter a task, it takes a lot of mental power, because we actually use a lot of power to compute to make the optimal decision. But as soon as we know what the optimal decisions are, we will try to find ways to do it quicker with less computation. So it's like when you move into a new flat, in the first days, you will spend 5 minutes looking, trying to capture the 5 photons that reflect off the light switch. But after a couple of days, you will just, without thinking about it, you will just touch it.
So we store the rules, right?
Yes, but
not all of the information.
Now,
just
exactly.
The
Now, if somebody would change the location of the light switch, then it wouldn't work anymore. So it's something that will depend on how the environment is. And I think animals are really great at also adjusting their models if they realize that things changed and the expected rewards are not as they used to be. But that's the key thing, that we actually have to be able to detect what the reward value is. And if somebody is messing with us doing that estimation or the reward is very distant or very complex to estimate, then it becomes more error prone.
And if we are being lulled into, as you mentioned, social media masquerading as a new environment to be explored, but at the same time feeling comfortable, is there a way to wake up from that dream or step out from that matrix? Or should we just say, oh, that's the fait accompli and let's live in it? No, I think it's, I'm a strong believer that we have to just simply consciously look at these problems and look at the potential biases that are biasing our own decision making. And if we identify them, we can simply respond and adjust our thinking. So I don't think this will ever stop. I don't think this is a bit like hackers and IT companies. So the arms race, right? It's an arms race. Okay. We always have to work on this. So maybe that's why there are so many. Yeah, maybe that's why there are so many books about this topic now, because we know that it's an arms race, and if we want to kind of be on top of the situation, at least to some degree, online or when using digital products, we have to at least understand what the hell is going on. Yeah. How do you see AI playing into the increasing complexity in which we are trying to make decisions today? How does it feed into our changing perception of reality as humans?
Yeah, so AI is very exciting from neuroscience point of view as well, because first of all, it creates a lot of hardware that can be used to actually look at neural data, but also people start to understand how their networks, or at least try to understand how their artificial neural networks process information and make the decisions. And so we hope that there will be some take-home messages from there for the brain. But I have to point out that there is quite clear differences between the brain and the AI. So first of all, a big difference is that neurons are spiking and AI networks are usually analog. And people try to build spiking networks for machine learning, but they seem to be performing less good as the normal ones. But it's getting there. And the other big difference is that what he told about the energy costs of things. So while we can throw as much power as we want onto AI, we cannot do that with the brain. So it has to cut more corners to get to the same decisions, and it has to get away with a cheaper solution than necessarily an AI has to. So one of the amazing things with brain that is blazing fast in the way it learns. So if you have a kid and you show him something once or twice, he's going to repeat after you. Even if, especially if something that he's not supposed to repeat after you.
Don't say that word.
Yeah, but in any other case, and in case of the artificial neural networks, usually people use hundreds or thousands of examples to train the network, and that's a huge difference in terms of speed. On the other hand, because the brain has this limitation of energy costs, I think in theory there is no reason why we couldn't blow up an AI to the extent that it's getting as complex as the brain and can do computation that is similar to that. I think we just have to understand much more about what the brain is actually doing and how it computes information, processes information.
So AI research helps us understand more about how the brain works and how our biases work. But on the other hand, when we do understand that makes the AI more powerful, right? Because we can feed that information back and create
That's true.
AI that can manipulate us better.
Yes, that's true. So I'm not a big optimist about AI and humans. So I think if you create something that is much more capable than us, then we will become irrelevant or less relevant at one point.
Even if we merge and...
So I think merging definitely is, and I'm also very interested in that, how we can connect brains to artificial brains, so to say, or machines. And I think it could be very useful, for example, in clinical applications. If you have something missing from your brain or not working fine, then you can actually fix that. And we can extend our senses, and we can extend our experience of the world, and maybe even boost our computational skills. But at some point, we will become like an irrelevant part of a much bigger thing, a much more complex thing. And I think that's quite unavoidable.
What should we do? What should a normal human being who is currently, stunned by their inability to make proper decisions on Twitter, Tinder, on Facebook or Booking.com because of the overwhelmingly changing environment, how should they prepare for something that's coming that's even more complicated and even more anticipating the human way of thinking?
Yeah, so I think first of all it's a responsibility of people who change things in big ways in our society to kind of limit the rate of the change, so to allow people to adapt to it, and also to provide tools that allow them to adapt to it. And I think what is important that we always keep in mind what is the individual interest of humans, and we are not serving something that is much higher order than humans and following some kind of basically social rules and play a game, but rather we try to always check again whether what we are doing and where the whole system is going is right or not.
Well, thank you so much for joining us today, and we really look forward to reading your articles.
Thanks
in the topic. Thank you guys for joining us. See you next time.
Bye.
Bye.